Darwin's theory of evolution by natural selection is the foundation of the biological sciences. It explains almost everything, from the biochemistry of bacterial metabolism to the mating behavior of whooping cranes. But then there are humans. We lack biological castes like worker bees or queens. Instead of inheriting our occupations genetically from parent to child, we possess a staggering behavioral plasticity, an ability to learn and invent an amazing variety of novel tasks. From the perspective of evolution, that extreme plasticity is dangerous. The capacity to make our own choices, our free will, comes with a heavy liability. We can choose to do things that contradict the biological imperative to reproduce, like taking religious vows of lifelong celibacy. Natural selection weeds out traits that lead to evolutionary failures. By all standard biological logic, evolution should actively oppose the development of behavioral free agency. Because our behavioral freedom is such an evolutionary liability, our very existence poses an unsolved puzzle. We are products of evolution, yet we possess a trait that contradicts standard models of how life adapts. To solve this puzzle, scientists have offered a few hypotheses. The first is sociobiology. Pioneered by researchers like E.O. Wilson, this approach attempts to explain human behavior using the exact same hardwired genetic models that we use to understand insects. To be fair, this model had one major success. It accurately predicted that humans have a built-in genetic aversion to incest, an adaptation selected to prevent the health defects and reduced fertility that arise from inbreeding. Anthropological evidence backs this up. When biologically unrelated children are raised together communally from infancy, like in 20th century Israeli kibbutzim, they show practically no sexual attraction to one another as adults. The aversion is hardwired. But the genetic model collapses when applied to more complex human social systems, like nepotism. Under a strict evolutionary model, humans should favor their actual biological relatives in economics and politics to ensure their own genes survive. In practice, biological relatedness is a poor predictor of human favoritism. In the Roman Empire, for instance, a ruling emperor would routinely bypass his own biological children to adopt his preferred successor, passing absolute power to someone completely outside his genetic lineage. Beyond history, there is a psychological failure with this theory. Ordinary people do not consciously operate as rational, Darwinian fitness calculators in their daily lives. Directly extending the rigid genetic rules of bees and ants to humans is inadequate. It leaves the paradox of our complex behavior unexplained. This brings us to a second hypothesis, the idea that our intelligence allowed us to escape natural selection entirely. This theory suggests we simply got smart and left our biological heritage behind. This chart maps the raw data of our hominin ancestors over the last 4 million years. You can see brain volume trending sharply upward, growing from about 400 cubic centimeters to an average of 1,400 cubic centimeters. But that growth came with a heavy biological cost. As this volumetric bar illustrates, adult brain tissue is metabolically expensive. Today, your brain uses up to a quarter of your body's entire daily caloric intake. To accommodate that growing brain, the human female body underwent a radical anatomical remodeling. The female pelvis changed in a way that compromised the limits of running speed, just to make room for the head of a newborn. Even with those structural changes, this physical bottleneck caused high rates of perinatal mortality. It also forced humans to give birth to vulnerable infants that require extensive care for years just to survive. We endure an immense caloric drain, compromised locomotion, lethal childbirth, and years of infant helplessness. This physical price tag is incompatible with the theory that our intelligence is a neutral trait. Evolution maintains tissue this expensive only when it provides a direct return on investment. Natural selection is ruthlessly economical. If our metabolically expensive brains were unnecessary, evolution would have rapidly shrunk them to the size of a chimpanzee's. Since they didn't shrink, they must have been actively sustained by strong natural selection up until the modern era. Yet, despite this intense selective pressure, human behavior lacks the predictable, rigid, hardwired programming seen in all other species. Our behavioral versatility is the specific target of natural selection. Evolution engineered our capacity for unpredictable choice. Free will is a high-cost biological mandate. Explaining the mechanism that evolution used to produce such a chaotic result remains the central challenge for biological science.